Alright, to make the next review of where we are with this accessory building, this was where Mike indicated the half bath should be located, 35 feet, and I took it 35 feet from the outside brick to the outside of this wall, and then indicated that the interior is to be 6 by 9. So these are the framing dimensions shown here. But zooming in on the bath, a 6 by 9 gives you room for a shower, the sink, and a toilet, and you even have space for a utility tub or something like this. The shower, this is a freestanding model, but usually I think these come this way, more rigid. And maybe just a little bit squeezed, because I think he also said you wanted 3-foot doors coming into this bath. So I think that's a little squeezed at 9.0, and this probably actually helps our overhang at 9.4. And this was an afterthought, but you have to call out which way you want that door to hinge. Zooming back out though and creating this storage platform over, this is what I ended up with, and I'll explain how that was arrived at. It's 13.8, on top of the platform from the inside of these walls to the edge of that framing. And these are the 2x12s that were rated to cantilever over here. And I'm showing 4 feet, and the reason I'm showing 4 feet is I'm assuming that these, and there's going to be a beam through here, we'll talk about that in a minute, but these members here, particularly out here, will go back to the inside of the sheeting and be nailed to the side of these vertical studs. These vertical studs have to be at 16 inches on center everywhere else anyway, because it's such a tall wall and it's got the brittle finish. So probably you run 16s here and run 16s on the floor, but you can, if you want to stop and frame this wall at 24 inches on center, that's going to be okay because it's got this platform. The reason this is like this though, so you can see that this is worked out so that if you buy 14-foot 2x12s, this is how you use that whole 2x4. You can go, as you'll see, we can go 5 foot for an overhang, but you would be buying 16-foot 2x12s and cutting a foot off of each one. And I guess if you were cutting a little more off of each one, you could use that as blocking through here, which is probably going to be required where it goes across the beam. And this is where they pass. This is this little study here. You can see a 5-foot overhang is doable. All right. The limit is reached at 5'6", where you can't cantilever beyond 5 foot. So that is the long and short of that. Is a 4-foot overhang is what I'm showing here. 4 foot from here to here. It gives you 13'8" up here. Now, that we need a beam underneath of those, and we're not going to be able to do this with a wood beam clear span like this 27 feet. But this was for this beam with a 4-foot overhang, selecting all of their products, all of their plies, and the results, the shortest one is 18, and that's 4 of those, which is kind of ridiculous in terms of cost. But the minimum with 2 is 22 inches. So that would make that space pretty much unusable if that actually is a clear span. And yes, that was for the full 27-foot span here, but 22 inches high. So, and that's probably going to be unrealistic to do that in one span without a column. So the next thing is splitting that span in 2, selecting all these products, and then we get a more reasonable solution of a couple 11s. We could go to 9 1/4, 3 of these for 9 1/2, 3 of these 9 1/2 for 9 1/4. But I'm working with these 11 1/4s in terms of our clearances and heights. going forward. This is a column, a footing and a column here, whether that's wood or steel, and whether the beam is steel or wood. They're both. Alright, here it was. I'm just going back here. To clear span it with steel is doable with a W10 by 45. So that one is about 10 inches high or so. Yes, a 10.1 high by 8 wide, and you'll have to have a plate on top of that too. So about 11 and a half net for a steel beam to span the entire thing with some sort of a footing and foundation, special foundation here, and what's happening back here as well. So maybe there's a little loss of that 27 foot, but that much is doable. Or with if you don't want to do the steel beam, the W10 by 45, then a couple of these LVLs through here with a column and footing here. And of course you have to allow room for these stairs as well, somewhere between 10 and 11 and a half feet. Just ignore this opening in the wall here. This short discussion is about the floor, the concrete floor. And now I'm showing this. Let's pretend, or let's assume that this is set level with the garages across the path. This, what you're seeing here, is this floor is sloped at 1/8 inch per foot up to the bathroom, and then it runs out level. In this, a little closer view, in this view, I've run the floor up. It's more than an 1/8 inch per foot, but probably not all the way to 3/8 or 3/16 per foot. It runs from the door up at that rate to the top of the foundation here at the intersection, or at the top at this is the midpoint, that 40 feet. Well, this is 35 feet actually from that end, but it runs up at that slope to that margin of where the bathroom is there and where this platform begins, and from that point northward it's level. Your concrete person might be able to advise you on this, but this is what I worked with going forward, was sloping it up to top of foundation here, and that's where we are before I put in the actual floor. Put in the floor, and there you see it come up. You can see it sloped down through here, and I'm doing my best to show this framing accurately. This gets framed as all these get framed as all tall walls, all at 16 inches on center. I will double check and see if these could be 2x10s on 16-inch centers, so that we don't have to have any kind of overbuying on the lumber. But this is what you end up with from the overview, roughly, with that floor sloped as I had indicated. So there's going to be a bunch of water back here. You might have to bring this foundation up out of the ground further, and then grade around that accordingly. If you want this floor to slope up like this, and you want some lift, which I would not mind seeing at least a couple inches of lift for these plates up here. So that's probably the adjustment we should make. This is the cut through the side then, and this is to talk about this platform and the clearances underneath and etc. This is showing that slab, as you can see it, it's up to the top of the foundation, and that means that underneath this platform is 7'4". More notably though, either with the steel beam or the LVLs, that clearance is down to about 6'5", which is a little bit. 6'6" is kind of the bare minimum. So we'll have to watch that and coordinate that with this floor. I think we already know that foundation is going to come further up out of the ground, but that doesn't have to do with so much with this, because this 16'4" from the top of the foundation is going to remain consistent. That will help us some though. So maybe in terms of raising this up and getting our clearance, you can see here, because I talked about putting those studs in beside and underneath these ones here, so these aren't relying on a nailed connection back here, but have trimmers underneath them going down. Perhaps those are bought as pre-cuts, 92 and 5/8, and then that platform has brought up that difference, which is about 6 inches. About 6 inches. So that means you would end up with that floor where I'm showing it, you end up with 710 underneath this platform, and about 7'0" to the bottom of this, which is fairly acceptable. I mean, that's decent. The bathroom is a similar thing, where the ceiling in the bathroom is at 88 inches, as shown. And so if we move that up another 6, that goes to 90 inches, which is probably the sensible thing to do. This was when I was first putting it together. That is how I would do it if I was right now. If I was advising you, I would say that's what we do. Bring it up with the pre-cuts and picking up that extra 6 inches. And there will also be another couple inches to spare. Now notice when we do go up that top gets shorter. So if we bring this foundation a couple more inches up out of the ground, maybe 3 or 4, and you just do a little grading out here, then we can get in a couple more. Whatever we bring this further up out of the ground than the 6 or so that it is now, or 7 or 8, we pick that up here. We don't really want to exceed this 16'4" net height of these walls. It does increase our building height and mass outside, though, which is what's next. And now, because I wanted you to get a feel for the mass of the structure, I did what I could to put together a quick rough model of the house itself in relationship to the accessory building, and just using just use the textures, just getting the colors fairly close. And I started horsing around with this roof. I mean, I think almost anything is better than a gable in this. It overpowers everything too much. And ultimately, I didn't think this was actually the answer either, because any of those hard edges with this house as it is, I just don't think are going to work as well at any height or pitch. This is where these pitches are all 5s, and this is like a vertical steel siding or some whatever, any number of vertical siding, and that increases this pitch to 10-12 like these, and cuts that down a little bit, which helps it some. But I still don't think it's the answer there. And right away, just go to the 10-12 pitch here. It's probably going to be easier for the truss people. So these ones here are 10-12, and then these are 5-12s here. And because it's 10-12 here, it just makes it even taller. This does not increase its height. It does trim some of that mass off by clipping back that front end. And roofing's cheaper than brick. So adding in the stone, or roughly the stone, and these are pretty much, this is according to the elevations from your drawings you sent over. I have this about 6 or 8 inches higher than this, just because of the mass of this. And then I was just trying to get, I guess that brick does have a little brown, and so does the stone. And so if these are too far off, but you should be able to get the rough idea from these. And you can see even these two, it's just, I mean, that in the right environment that could work, but, and I thought of, I mean, if you bring these margins here back some more, then maybe you can put big, but they would probably be fake, I guess, big end vents in here, which might have a more, and then reduce the length of this ridge. I don't show this, but you reduce the length of that ridge, and I don't know if that gets big farm vents. I guess it's a case of what you're looking for there. But going to this again, this is always what I settle on in terms of our choices, which are fairly limited without just adding expense, and I don't want to give this accessory building any more than it needs in relation to the house. But I did want to, see, I'm not worried, personally I'm not worried about the height of this. I would not bother breaking that down. Whatever this is here, this is just a little higher than that, about 8 inches. Well, the door is 80, so this probably comes up 56 inches maybe. But it helps the scale of everything, I think. And yeah, it's a big building, so you're going to have that kind of scale. I'm not sure This just, is showing you that elevation and scale mass. And even this is a pricey undertaking. You see there's 7 of them, and I'm not sure that that's really doing what you need it to do there. So that one and this one with no windows, I'm going to show you some the 3-dimensional kind of turnarounds, and those are run silent film style.